There's a place so distant, its light has taken over 13 billion years just to reach us. Not just far, but ancient. A silent signal from when the universe was still learning how to breathe. And now, for the first time in human history, we've seen it. When the James Webb Space Telescope turned its gaze to the stars, it didn't just send back pictures. It tore through the darkness of time. It pulled back the curtain and revealed something no one had ever witnessed: the edge of the observable universe. From where the very first stars were born, to the light stretched thin by the endless expansion of space, Webb is taking us back to a moment when the cosmos first began to tell its story. These are the first images. This is where light meets time. This is what NASA saw at the edge of everything. Let's begin with the telescope itself, because to understand what it saw, we need to grasp what it is. Launched in December 2021 after decades of delay, cost overruns, and engineering miracles, the James Webb Space Telescope was never just a better version of Hubble. It was something else entirely. Engineered with 18 gold-plated hexagonal mirrors, a sunshield the size of a tennis court, and the ability to see in the infrared spectrum. Webb was a $10 billion bet that we could glimpse light from the first galaxies, light that's been traveling through space since the universe was young. Webb had to be folded like origami to fit into its launch vehicle. Once in space, it took a full month to unfurl, calibrate, and position itself into a perfect orbit far beyond the moon at Lagrange Point 2. Any one of over 300 possible failure points could have ended the mission. But it worked, and the universe started revealing its secrets. What makes Webb special isn't just that it's powerful, it sees what our eyes cannot. Unlike Hubble, which sees mainly in the visible spectrum, Webb sees in infrared. That means it can see through dust. It can detect cooler objects. And most importantly, it can see ancient galaxies whose light has been stretched by cosmic expansion into long red wavelengths. Imagine watching a firework explode and the light from it traveling toward you for 13 billion years. That's what Webb sees. One of the most iconic early Webb images, the cosmic cliffs. This stunning landscape is part of the Tarantula Nebula 7600 light-years away. Webb's infrared vision peels back clouds of dust, revealing stars being born. These stars form from dense clumps of chai heated and pressured into ignition. What once looked like a blurry gas cloud through Hubble's lens now comes alive with structure, shape, and motion. Scientists can now watch the stages of star birth, some of them for the very first time. But Webb doesn't just show us the beginning of stars, it shows us their end. This planetary nebula is the remains of a sun-like star. Webb's instruments captured it from multiple angles, revealing not one, but two stars in the system. One is nearing death, shedding gas into space. The other still stable orbits silently. By analyzing the gases, scientists can understand what elements are being sent into the cosmos: carbon, oxygen, and more elements that may one day form planets, plants, or even people. Next, Webb turned its gaze to the Tarantula Nebula, a massive star-forming region 161,000 light-years away. Why here? Because the conditions in this nebula resemble a time period known as cosmic noon, a billion years after the Big Bang, when star formation peaked. By studying it, astronomers can learn what the early universe might have looked like: chaotic, dense, glowing with the heat of newly formed suns. Some of the stars Webb saw were only 20,000 years old, mere infants in cosmic terms. Let's zoom out. Individual stars become too small to see. What we find instead are galaxies, billions of them. One of the most dramatic Webb images, Stephan's quintet. 5 galaxies. 4 actually near each other, 1 just in the foreground. Webb captured 2 of these galaxies in the middle of a cosmic collision. Their gravitational pull is shredding their structure, causing massive bursts of star formation and hot dust clouds that light up Webb's sensors. This dance of destruction and creation is how larger galaxies like our own Milky Way come to be. Now, brace yourself. One of the most important images ever taken in Webb's first deep field. This patch of sky is tiny, equivalent to a grain of sand held at arm's length, yet it contains thousands of galaxies. The light from some of them has taken 13.1 billion years to reach us. We are seeing them as they were when the universe was less than 700 million years old. It's like looking into a time machine. One galaxy, a faint red smudge, is one of the oldest ever discovered. Webb took just 12 hours to capture this. Hubble took 10 days for similar images. If Webb stared at this patch for days or weeks, who knows what else we might find? Let me take a moment for a personal reflection. As a child, I remember being obsessed with the stars. I'd lie on the roof of my house trying to spot constellations through city lights. Back then, the idea of seeing other galaxies, let alone their birth, felt like science fiction. Now, we can. But more than that, Webb is now peering into exoplanet atmospheres. It's analyzing starlight passing through alien skies, picking up chemical fingerprints of gases like methane, carbon dioxide, even water vapor. It's too early to declare life out there. But for the first time, we have a tool that might just help us find it. Webb is a telescope, yes, but in a way, it's a metaphor. Think of all the things in our lives we ignore until we have the right lens to see them. Mental health issues invisible until they erupt. Climate change data once hidden, now undeniable, and injustices buried under centuries of dust. Sometimes seeing clearly requires new instruments. Webb, in that sense, is not just a telescope, it's a reminder that our understanding is limited by our tools. When we upgrade those tools, we upgrade ourselves. The James Webb Space Telescope is only just beginning its mission. It will operate for at least a decade. But what it's already shown us is breathtaking. It's proven that we can build miracles. We can look further back than ever before, and we are capable of finding beauty and wonder in even the darkest corners of existence. There will always be more to see, more to question, more to understand. We used to look at the stars and wonder if we were alone. Now we're looking back in time and discovering that the universe has always been more beautiful, more violent, and more mysterious than we ever imagined. So the next time you look up at the night sky, remember the edge of everything is just the beginning.